Astronomers discovered a giant rocky world 23 times more massive than Earth. According to current planetary formation laws, it should not exist. In the standard model of how planets are built, cores start by gathering rock and metal, but there is a critical limit to this growth known as the rule of 20. Once a core reaches roughly 20 times the mass of Earth, its gravity becomes strong enough to vacuum up hydrogen and helium from the surrounding space. This inevitable gas accumulation forces the planet to evolve into a gas giant. You can see this physical law at work in our own solar system with Jupiter. Like Saturn, it reached that mass threshold and rapidly pulled in an enormous gaseous envelope. Because of this rapid growth phase, finding a purely rocky world of this scale was thought to be a physical impossibility. But data from NASA's TESS satellite and the YEN telescope in Arizona revealed an anomaly, a world designated GJ523b. Calculations show the planet has a mass 23.5 times that of Earth. That weight puts it significantly past the threshold where a massive gas envelope should have formed. Yet all of that mass is packed into a radius only 2.5 times wider than Earth. This extreme density, roughly 127 grams per cubic inch, confirms the planet is almost entirely rock and metal. It lacks the thick, low-density atmosphere of a gas giant. GJ523b grew far beyond the expected mass limit without ever accumulating a significant atmosphere, presenting a mystery that current formation models cannot easily explain. To understand how this world formed, researchers began looking closer at the planet's environment and its history. GJ523b sits incredibly close to its host star, completing a highly irradiated, blisteringly fast orbit in just 17 days. The planetary system itself is also remarkably young, estimated to be only about 169 million years old. That youth is a problem for the theory of photoevaporation. GJ523b hasn't been around long enough for a gas giant's atmosphere to have simply boiled away over billions of years. Its path is equally strange. While most planets circle their star's equator, GJ523b sits on a nearly vertical polar orbit tilted at an angle of 71 degrees. These factors point away from a peaceful, steady formation and toward a much more disruptive and violent origin. One possibility is a theory known as gas pore migration. This suggests the planet formed in a distant region of the solar system, completely devoid of gas, before being violently yanked inward to its current position. Another, more favored hypothesis is the giant impact. Under this model, two massive rocky protoplanets slammed into each other, merging their dense metallic cores into a single colossal mass. The sheer energy of such a catastrophic collision would have blasted their original gaseous atmospheres permanently out into space, leaving only a bare rocky core. While the exact details are still under investigation, it is clear that extreme cosmic events are required to forge a world this dense. The discovery of GJ523b has forced astronomers to formalize an entirely new planetary classification, the mega-Earth. This chart graphs planetary radius against density. To be classified as a mega-Earth, a planet must have a radius at least 2.1 times that of Earth, and a bulk density exceeding 5.5 grams per cubic centimeter. To understand the broader rules for these worlds, scientists are now searching for a larger sample size of 20 to 30 similar overdense planets. GJ523b has moved from being a single anomaly to the defining example of this new planetary class. The next stage of the investigation involves the James Webb Space Telescope. Scientists are using Webb's instruments to look for a thin secondary atmosphere composed of heavy molecules like water vapor or carbon dioxide. The chemical makeup of that atmosphere will help determine whether the planet migrated from a distant ice line or is the remnant of a catastrophic collision. GJ523b proves that the universe is governed by chaotic, violent processes capable of creating worlds that were once thought to be impossible.